अपने गलत हो गया ना जेटी पड़ा ना या जेटी पड़ा ना क्या लेके पड़ी चला पड़ा वाले वाले निकला
So I just mentioned you earlier the two peaks for this molecular ion over here. Okay, one for the molecule which is containing for Br79, one for Br81 isotope. Okay, now because the two isotopes are of similar abundance, okay, they give similar abundance and therefore their peaks are of the similar height. So I'll just write that part over here. Tell me once you're done with this, then we'll move on. Okay.
Yeah. Done.
Done.
Yeah.
So this was of haloalkanes. Now what are we going to see is that of alcohols. Tell me, what do you know about alcohols?
They're very soluble.
Okay, very good.
They also have like higher melting points,
Okay,
much
alkane.
higher than
Yes, they have a
alkane.
higher boiling point. Okay, alkane. And one thing, different factor from that of alkanes is alcohols contain this OH group in them, right? And
Yeah.
this OH group, what do? Is they react, or they take one hydrogen ion from the other compound and they give a loss of water molecule. Okay, so it is very easy to obtain a loss of water molecule whenever alcohols is present. So what happens here is because of this loss of water molecule, they give a peak at 18 below the molecule ion. Okay, so they give a peak at 18 below the molecular ion. Okay, and there are other common peaks which are occurring, and that is because of the breaking of the carbon-carbon bond. This carbon-carbon bond bearing the OH group and another carbon atom group. Okay, and because of this, what you produce is alcohol, methyl alcohol. So now what are we going to see is an example of propane 1-ol, that is CH3, sorry, I'll write it this way, it's C3H7OH. So what I'll do is, first I'll write how they are getting eliminated, how this water molecule is getting eliminated at each and every stage, and then I'll draw you the peak level, okay, peak graph. So I have CH2. Okay, this is how they are getting breakdown over here. Butanol, which is made from butane and water. Okay, they get butanol. This butanol breaking into propene and methyl alcohol, which gives out propene and methyl alcohol in this way. Okay, and then what is left back is propane here. Propane and propene.
Is the dot lone pairs?
Lone pairs, yes.
Yep, done.
Done?
Yeah.
Okay, so I'll draw the peak graph now. So these are the values and the values for which they stand for.
Yeah.
You're done?
Yeah.
So this is mass spectrometry, okay, for this organic chemistry part. Because earlier we have seen is alkenes, haloalkanes, alcohols, right? So in relation to that, we have seen different peak levels. Now what I'm going to tell you is regarding the mass spectrometer, that is the device.
Yeah.
Okay, so the mass spectro device, the operation, the main operation or the role is spectrometer consists of an ion source.
Does that say operation?
Operation, yes. So first I'll write down what is an ion source, what is an analyzer, and what is a detector. And then with the help of a small diagram, I'll make you understand how that entire spectrometer works. Okay.
Yeah. Does that say bombarded?
Yes, bombarded. A small sample of compound is bombarded with electrons. tell me once you are done. By the time I'll just draw the diagram. So the diagram for you.
Yep.
Okay, so here we go. So this is my ion source. Okay. Now what does ion source says? It is a small sample of compound which is bombarded with electrons. Okay. So this ion sample or ion source, it's full of electrons, right? Okay, it is bombarded with electrons and they are ionized. Then a fragmentation ions, they are accelerated by an electric field and only ions are affected. So from these electrons, only those which are ions which are accelerated by the electric field, they are being affected. Okay, so from this ion source, what is happening is they undergo through analyzer. So what comes here is the next thing is they have another small apparatus. Okay, then we have the analyzer. So here I'll draw the analyzer. And here I have my detector. Okay, so I told you what is an ion source. Okay, it is full of electrons. Now this is your analyzer. Now what does this analyzer does? This analyzer, it separates the ions according to their mass. Okay, it is separating according to their mass and so according to their mass charge. Okay, then also the radius of the path, it is depending upon the value of the mz value. So if you have a source or any ion particle, what color shall we take? Let's take black for instance. It is traveling, okay, from the ion source through the analyzer and it is moving up till here. So once it comes near to the analyzer, say let's say halfway to the analyzer, what is happening here is they change the colors. Okay, the path changes. So what is the role of the detector now? Now the analyzer, I said, they separate the ions. So now they start separating this way. So one moves this way, another moves this way, and let's say one more moves this way. Okay, and now what is the role of this detector over here? The electric or the photographic detection methods observe the presence of ions. Now we have three different ions over here. 1, 2, 3. So with the help of this detector, we are able to identify what ions have been affected and which of them have come out. Okay. So this is how they travel from the ion source through the analyzer and then to the detector part. Okay. This is a magnetic field which is present over here. Okay, this is a magnetic field which is present over here. So this is how a mass spectrometer works. So when, if you, without giving you what source is this, and if you find out what ions are these, and with the help of the peak, you can identify what was the main compound over here.
Yeah.
Okay, so
Mhm.
done with mass spectrometer.
Could you show me how to um answer one of the exam questions on this?
Exam
Like if you're
questions.
given
Yeah,
the graph, how to find out
okay, fine.
the end product, please.
So you want the one with the graph.
Yeah.
the simple ones first, okay? So we have got one set of questions. So have you got?
Yeah, I can see it. Can you go through it now with me? Because I don't like understand how to answer the questions.
Okay, no problem. First one says, deduce the relative atomic masses of the following elements. So now what elements have been given to you? Silicon, silver, boron, gallium and zirconium. Zirconium they have not mentioned anything. Okay. and they have given you a graph value. Okay, so they start ranging from 90, 91, 92, 94, 96. Okay, how are you going to deduce the relative atomic mass number? They have given you the abundance rate. Can you see? Everyone has relative abundance.
Yeah.
So how are you going to do it? Which one has the highest abundance in silicon?
28 SI.
28 SI. Okay, that is SI is silicon. Okay. Now 28 SI gives you how silicon gives you how much? 92.21, right?
Yeah.
Okay. Here I have not drawn the graph properly. Okay. So you just have to see which of them is giving you the highest amount of abundance value. That's it. For the first one, that is the answer. Okay. For each of the following, you just have to identify which of them has the highest abundance among all these isotopes. For the
Yeah.
okay, so that is done. First four. Okay. Please, zirconium, we need not do that, okay, because they have not given us any value. Sixth one, bromine has two isotopes with mass number 79 and 81. Its relative atomic mass often given as 80. What does that tell you about the relative abundance of the two isotopes? I think you can refer the one which we have done with bromine earlier. Halogen alkanes. Okay, we use the same example, I think, bromine with isotope 79 and 81. So that is also the answer is given for you. Seventh one, most argon atoms have a mass number 40. How many neutrons does this isotope have? So they have given you the mass number. The relative isotopic mass of this isotope is 39.961. Now see, they have given you the mass number. They have also given you the isotopic number over here. But the relative atomic mass of argon is 39.948. What can you deduce about the other isotopes? Now you have one isotope value. Yes. And they are asking
Yeah.
about another one. So what can you, you just first have to answer the number of neutrons present in them, right? First,
Yeah.
to identify the number of neutrons. So with the help of the mass number and with the help of the atomic mass number, you can identify the number of neutrons. What can you deduce about the other isotopes? You can just say that they will be lighter and they won't be much more abundant.
Yeah.
Okay, so that will be for the seventh one. I think you can do this also right now. Then ninth one, deduce giving reasons the relative molecular mass of compound A which has a falling mass spectrum. So they have given you a certain falling spectrum values over here and they ask you to deduce the molecular ion, right? Molecular mass. Okay, what do you think will be the molecular one?
Is it the one right at the end?
Very good. So 72, right?
72.
Yes, that's it. So this is a very simple one which I have given right now.
Oh, right. Is there anything else I need to know in this topic?
No, I don't think so. If I have, I'll just...
Is this in the organic chemistry topic, like or is it in a different topic?
It's there in organic chemistry. I've taken the ones like how did we follow alkane, alkanes, alcohols. So according to that, I took that organic chemistry part, mass spectrometer.
Okay.
Do you all have it in a detailed way?
Sorry?
Do you all have this topic in a detailed way?
I don't think so.
Because organic chemistry, if you go through it, only this much is involved in that. I mean, they have given you
Yeah.
spectros. If you want, I'll just see if I have any other questions. What is the next topic you would like to start with?
I'm not sure yet.
Fine. So I'll just send you a link, you can go through the questions, and if you have any difficulty, you can just keep it and you can ask me for the next class.
Okay.
Okay? So I've sent you a link. You will be finding a number of questions. You go through them, see which of them you are able to solve. If you can answer them, well and good. If you can't, just keep it for your next class. If we have time for them, we will be discussing it for the same.
Yep.
Okay.
Wait, where's the link?
I just sent it to you in Skype.
Oh, okay.
Yeah.
Yeah.
Okay. So shall we end up a class over your case then?
Thank you.
Okay.